Let's start. So yesterday we were doing, okay, say the question is you have been given a resistance, a diode, three diodes. I'm solving sheet one, sheet one, and this is a resistance. You have a 10 volt, and this is the grounded. Now the question this is design a circuit whose output is 2.4 volt. Okay, the output is 2.4 volt. Here I'm measuring the output. It should be 2.4 volt, and also given that if voltage drop across a diode is 0.7 volt, okay, at 0.7 volt the current flowing through the diode is 1 milliamps. Okay, so question says that if you have a diode, single diode, okay, and you're applying a voltage say 0.7 volt across this diode, the forward current is 1 milliamp. Okay, if you are, of course you are applying some voltage which is variable voltage, okay, and the drop is here 0.7 volt drop is here 0.7 volt, then the current is 1 milliampere. And the if you change the this voltage, because diode voltage is not fixed, okay, it varies slightly, it varies slightly. Now if you change the applied voltage, of course some resistance will be there, and the voltage become say 0.7, 0.7, it is say 1 milliamps current. This is id, and this is the voltage across the diode. Okay, if at 0.7 volt the current is 1 milliampere. Now if you make it 0.8, the current becomes 10 milliamps. It is given, okay, that each 0.1 volt increase voltage, there is the current will multiply by 10, multiply by 10s. Okay, so first of all we have to find what is the current flowing here, what is the current flowing here in this circuit. So for that they say you design a circuit with 2.4 volt with three diodes. That means the voltage across each diode will be how much? 2.4 divided by 3, that is 0.8 volt. The voltage will be 0.8 volt across each diode. 0.8, 0.8, and 0.8. Now at this voltage the current will be 10 milliamps. Okay, so that means this current is flowing, which is that is equal to 10 milliamp till 10 milliamps. And now I have to find the value of R. So I can find the value of R. Okay, so R will be, tell me R will be what? So IR, so R will be your 10 minus this 2.4 volt, and current flowing is 10 milliamps. So this will be how much? 10 minus 2.4, how much will be there? 7 8 point or 7 point? 7.6. Okay, so 7.6 this will become and this is your 10 power minus 2, so we multiply, this will become 760 ohm. Okay, so this is the value of R for this circuit. Okay, so if this point is question is clear, we can move to the next question. अगर कोई doubt है किसी को, then I will discuss once more. Okay, shall I go to the next question? Okay, now the next question is from again Gina diode. Say Zener diode whose nominal voltage is 10 volt at 10 milliamps has an incremental resistance of 50 ohm. Okay, so this is the example. Okay, like we have discussed in the class piecewise linear model. So in piecewise linear model, you say diode has some voltage drop plus it has some resistance. So now because now if I say this is my ID and this is my VD for Zener diode. So here it is ordinary diode, okay, plus some resist. See, if it's a constant model, then what will happen here? The voltage is fixed, but it is some resistance also. Then voltage is not fixed. Current is there is some slope. Similarly, if I want to plot the IV characteristics in a reverse bias, then generally we plot like this straight. So when a state is there, the Zener voltage is fixed. But if it has some, if I replace a Zener diode, if I replace a Zener diode with a battery in reverse bias, and and a resistance RZ, say RZ, VZ. Generally, we replace Zener diode in reverse bias if the voltage is greater than VZ by a battery. But here we are going to replace. We can replace also with a resistance also. Okay. Then in that case, what will happen? This slope will not. This will be like this, slightly like this, slightly, and this will be tilted. So your voltage is also Zener breakdown voltage also not fixed. It is varying little bit with due to the resistance. Okay, so this concept, these things we have to implement in this question. Are you getting what I'm saying here?
सर एक बार रिपीट करना.
जैसे हम लोग क्या करते हैं, डायोड जैसे हमारे पास सपोज वी हैव ए नॉर्मल डायोड में क्या करते हैं हम लोग, बताओ. ये मेरा नॉर्मल डायोड है. ओके, आई रिप्लेस जनरली इट बाय अ बैटरी ऑफ 0.7 वोल्ट in forward bias. Yes or no? And sometimes we say there is a resistance also in piecewise linear model. In constant voltage model, I say this is a 0.7 volt, and when I use a piecewise linear model, I say there is some resistance also involved. Okay, similarly here in the reverse bias, now I'm saying that I can, because it's the voltage regulator, generally the voltage is fixed across the Zener reverse bias across the Zener diode, but now I'm putting a resistance also. So the actual characteristics will be like this: some resistance variation, some voltage variation will be there from here to here. Okay, in the across the Zener diode. Okay, so let us understand this with a question. What question is saying? The question says a Zener diode whose nominal voltage is 10 volt at 10 milliampere has an incremental resistance of 50 volt. What voltage do you expect if the diode current is half doubled? So because now I can write this VZ I can write because I can replace it by battery. Okay, so this is my Zener diode. I'm plotting again. Plus minus. Now I can replace this by a battery of VZ0 and a resistance RZ. Okay, so now whatever voltage drop is there is there. This total will be your VZ. So this total will be now your VZ. So I can write VZ is equals to VZ0, which is a fixed battery, plus RZ into I, how much current is flowing through the Zener diode in reverse bias, that is equal to RZ IZ. Now in the question says this is a 10 volt at 10 milliampere. Okay, so VZ is given 10 volt. Okay, VZ0 we don't know actually, because now whatever VZ is given, total VZ is given 10 volt plus RZ is given 7 ohm, 50 ohm. Incremental resistance 50 ohm, and the current is given 10 milliamps. 10 milliamps. Okay, and this is always fixed, but here the drop will always change with the current. What is the if current changes, this drop will change, but this battery will be always same. Okay, now I want to find what is this VZ0. So this is 10 volts, so this will be VZ0 plus how much will come? Tell me. 500, 0.5 volt. Correct? So my VZ0 will come now 10 minus 0.5, that is 9.5 volt. 9.5 volt. Okay. Now question says, what is the voltage do you expect if the diode current is half and doubled? Okay. Now I want to find VZ. So VZ is fixed now. VZ0 is fixed. I know it is at 9.5 volt. Resistance is fixed now, 50 ohm. Now current is half. So earlier it was 10 milliampere. Now make it 5 milliamps. So what will the new voltage drop across the Zener diode? Tell me, कितना आएगा? This is 250 to 10 to the power minus 3. So this will be 9.75 volt. Similarly, if I is doubled, this I now here I is 10, here was I was 10, now I is 5 milliamperes. Now see if the I is 20 milliamperes, then similar way you can calculate. So VZ will be 9.5 plus 50 into 20 milliamps. कितना आएगा बताओ? 9.5. This becomes 1001. So this becomes 10.5 volt. Is this question is clear to everyone? So now I'm changing Zener diode, replacing Zener diode with the battery as well as a resistor. So because of that, now Zener diode voltage, even though the is not fixed, okay, when it is in conducting state, it is the voltage is not fixed. It is varying with current. How much Zener is varying, okay? So that is the Shreya. Is that clear? Ayan, Anshuman.
Yes, sir. It's
Hmm.
Yes, sir.
So can I go to the next sheet, or if you want me to solve one more question?
Sir, do that one more question.
Which one?
One more question is left, right? A shunt regulator utilizes.
This is same question like a, a shunt regulator is utilized a Zener diode whose voltage is 5.5 volt at current of 5 milliampere and whose incremental resistance is 70 ohm. The diode is fed from a supply of 15 volt nominal voltage through a resistor. Okay, what is the output voltage? What is the output voltage at no load? And find the line regulation and the load regulation. Find the line regulation and load regulation पूछा है. What is line regulation and load regulation? First understand that one. So say I have been given a battery. Battery is how much? Battery is 15 volt. So battery is 15 volt and resistor is 200 ohm. Resistor is 200 ohm, and then you have been given a Zener diode. Okay. And here some load is there, RL. You can make it open also. Okay. Some load is there, which is variable. Is that clear? Is the same thing what I'm saying. So now, first of all, so Zener voltage is 5.1 volt. Okay, this is required 5.1 volt. Okay, so of course if I make it open, I can make it, so assuming it is conducting, okay, assuming it is conducting, so I can replace it by a battery as well as what? As well as a resistance. Resistance, what is the value of resistance? Tell me. What is the value of resistance?
7 ohms.
7 ohms. Okay, so this is the value of resistance. Now I have to find what is VZ0. Total is 5.1 is given. Okay, so VZ is equal to VZ0 plus IZ. RZ is given. So this is given 5.1 volt, and VZ0 IZ is how much? 50 milliamp. 50 milliamps. Yes, 50
Yes, sir.
50 milliamps. And this is your 7 ohm. Tell me what is coming VZ0? 5.1 minus this is 350.35. 7, okay. 0.35. Tell me how much will come this value? What is the value?
1.6.
5.1 minus 0.35. 4.75. Correct?
Yes, sir.
4.75 volt. Okay. So this is VG0. This is the first answer. Okay. So what is the output voltage? So this is 4.7. Output voltage is always fixed to 5 volt. Okay. So this is the output voltage. Okay. So output whenever it is conducting, output voltage is 5.1 volt. Now it says output voltage at no load. If I remove this load, okay, if I remove this load, so output voltage with no load is 5.1 volt. Okay, because whatever current will come here, that current will flow here, and the voltage is fixed here. Okay, whatever here you are this is fixed, because this is fixed. So obviously current going through this general is fixed. So when the fixed current is there, then you have a fixed voltage drop here. That's the first thing. Okay, now what is the load regulation? Okay, load regulation means you are keeping the input voltage fixed. Load regulation. So what is the effect of load on this? Because if it is a battery, even I change the resistance, nothing will this voltage will not change. But now if I change the RL, okay, so some current I is coming, IZ is coming here, IL is coming here. Now if I change this resistance RL, my IL will change, and accordingly IZ will also change. Now this output voltage is not fixed like 5.1 volt. If no load is there, then 5.1 is there. But because now changing the resistance will change the current, because I is what? I is your IZ plus IL. And now if I change the resistance here, the voltage, so current will also change. Some variation will come. So this voltage will vary. Okay. So this is called load regulation. So load regulation is called change in output voltage. If I say this output voltage with change in the load current IL. And the load current varies because of the variation of load resistance. This is called your delta IL. Okay. Now say delta IL, I can say delta IL will be minus delta Z. Because if IL increases, Z will decrease. If this decreases, this will increase. So there's a change in IL will be always negative of change of delta IZ. Now I want to find what is delta V naught. Okay, suppose there is a change of current is 1 milliamp, 1 milliamp change in the current. Okay, so if there is a 1 milliampere change, so delta IZ is say 1 milliamp. Okay, then how much this delta change in delta V naught? If there is a 1 milliampere current here increases or decreases, okay, so say how much the change will come? So delta V naught will come 1 milliamp into 7 ohm. okay, 7 ohm for change of 1 milliamp. Okay, so this should come and with a minus sign, minus. So this will be minus 7 millivolt per milliamp. Okay, so this is the voltage load regulation for this, or volt per ampere, volt per ampere. So minus 7 volt per ampere voltage regulation.
Sir,
Tell me.
how we get that 1 milliampere, or we are just taking some value?
It's getting some value. If I change the 1 milliampere, I change in the 1 milliampere changes how much the, this is the definition na? Per unit, per unit I change in IZ, per unit change in IL, how much is voltage change? Okay, that is, so delta IL is 1 milliampere, delta IL will be also 1 milliampere. So the change here will be, that is 7 millivolt, or what is 7 volt per. Okay, similarly line
सर
regulation
वो
is what?
माइनस साइन कहाँ से आया उसमें?
ये डेल्टा IL, चेंज इन डेल्टा IL विल बी नेगेटिव ऑफ चेंज इन डेल्टा IZ. ओके, सिमिलरली लाइन रेगुलेशन क्या होता है? लाइन रेगुलेशन का मतलब होता है change in the output, change in the output due to change in the input. Okay, if you changing the input, then how output is changing? Okay, say this is my V naught for 15 volt. Now I will say 15 volt plus delta VI, say 15.5 volt. So how much voltage will change? Okay, so the how much voltage will change, that means if I put it here a source of delta VI plus minus, okay, then how much current, how much change will come here? Delta, this is 7 ohm. So how much voltage, how much delta V naught will come here? That you have to find out. So tell me, what should I write here? 200 ohms is there. 200 ohms. So I can find, this is fixed. So whatever change will come here only. Here. Delta V naught. So delta V naught will be how much? Tell me. So delta V naught, this delta V naught will come.
IR.
Total delta VI. Okay, total resistance is 200 plus 7. 200 plus 7 into 7 into 7. This is delta V naught divided by delta V input. Okay, into percentage. If you want percentage, you can multiply. So this is basically your line regulation. Line regulation will be now how much? This is cancelled. So 7 upon 207. How much is coming? Tell me. Solve it. We say if you're changing 0.5 here, how much change will come here? Simple, that one.
0.03.
0.03. Okay. Suppose this has become now 15.5. So how much you can find the current? How much current is the circuit? Okay, and you can solve. You can solve this one this way. So directly, this is basically it will be only the ratio of the resistance only. Or you can put the values and you can find some values and you can find this is 0.033 if the values are given in the exam. Okay.
सर एक बार लोड रेगुलेशन वाला भी कर दीजिए.
Load regulation क्या है कि this one ना, what is the change in the output voltage with the change of load current, and load current changes with the load resistance. If you change the load resistance, the IL changes. Okay, so if IL changes, this IZ changes, and if IZ changes, this total voltage will change. This is fixed, but since current is changing here, this voltage will change. This ratio is called your load regulation, and delta IL is equal to minus delta IZ. If I say there is a 1 milliamp change in the current and IZ. So here the delta V naught will come how much? 1 milliamp and 7 ohm, because this is a fixed. So 1 milliamp change is there, that there can be plus or minus anything. Okay. So this is this one, so that you can write like this, minus 7 millivolt per this one. Can we go to the next sheet now? So the next sheet is from, say, I put it, we have done so many problems, DC biasing problems we have already done. So I purposefully put given some AC problems here, na, in the sheet number 2, so that you should practice some amplifier questions. DC questions we have already done so much in the class. So say question number 1. So let us understand first what is the amplifier circuit once more. Common ammeter configuration. So this is common ammeter configuration, and this is your base. Okay, here you have a resistance. Say this is voltage divider circuit. Here you have ammeter resistance RE. Generally we say this is R1. We say this is R2, and we apply here. We put also one RCC here. RC here, and then we supply power supply VCC here. Okay, so this is my DC biasing, voltage divider circuit in DC biasing. Now I want to apply AC source. I want to use this circuit as a AC amplifier. So just what I'll do, I'll put it some coupling capacitors here, and I'll apply some B input here. Okay, and I'll measure this V output here. I'll say this is my C1 and this is my C2, and I can put one capacitor if I want. I can put it here. Then this is my C3. Okay, so this is my basic amplifier circuit. I say C1 and C2 are coupling capacitors. So C1 and C2 are coupling capacitors. Coupling capacitors. Okay, and C3 is bypass capacitor. Okay, bypass filter or bypass capacitor. Now you can understand that the reactance of a capacitor, if I say XC, is given by how much? What is XC? What is XC? XC कितना होता है?
1 by j omega c.
J omega C. Okay, 1 upon j omega C, or I say this is 1 upon j 2 pi FC. So I can say my XC is proportional to 1 by F. Okay, so if my frequency is low, my XC is high. If my frequency is high, my XC is low. So for high frequency, the XC is low, so I can replace by a short. This is short circuit. This I can replace short circuit. This I can replace short circuit. And if there is a DC, F is 0, X is infinite, so I can treat this as an open circuit. This is open circuit. This is open circuit. This is open circuit. So basically, whenever I apply DC biasing, whenever I'm calculating the operating point, okay, so these capacitor will become open. Okay, so the what is the use of C1, C2? Okay, so C1, C2 are basically for DC isolation. These are used for DC isolation. The purpose of C1, C2 is DC isolation. Whenever I want to fix the operating point of this transistor before applying the input, this will become open, so input will be out of picture. Output I'm not measuring. Okay, input is not affecting my circuit because this DC isolation is there. Okay, for DC this is open circuit. And this is your this is also open in DC case. Isolation also giving. Now, what I will when I apply AC? Okay, so when I'm applying AC of high frequency, so this will become short, this will become short, and this will also become short. Once this has become short, this is also removed. Okay, but that depends on the frequency value. What is the frequency? What is the XC value of this capacitor? Okay, so now whenever frequency increases, generally your gain increases, because if I write the gain of this circuit, this is the ammeter resistance. Okay, ammeter resistance generally we replace by RE. So can anyone tell me what is the gain of this circuit? What is the formula for gain of this circuit? We have done in the class. Shirin, Lipsa, what is the formula for gain?
Sir, for beta.
Voltage gain. Because amplifier, na? What is the formula of voltage gain? The
The
formula
output.
the voltage gain formula is your RC upon this is small re, small re plus. Now this is a combination. I write by ZE. This is your formula. Okay. If I write a combination, this one ZE is what? ZE is basically RE parallel to C3 XC parallel to XC3. This is the formula. Now, if it is a high frequency, this becomes 0. Okay, for high frequency, my gain will become what? RC by RE. Okay, because now this part becomes short if it is very high frequenzy. So I can put ZD is 0. This is 0 means parallel is also 0. This will make this short. So for high frequency, I generally use this formula we already discussed in the class. People don't revise. So RC by RE is the gain of this circuit for high frequency. Okay, and if it is the very low frequency, I can make it open. So my gain will be only for low frequency. So very low frequency. For very low frequency. Okay, my gain will become what? RC plus RE plus, if low frequency, this is infinite, I can make it open, only RE. Okay, so this is the actual formula. This is for very high frequency, this is for very low frequency. I can use this this formulas. Okay, so if frequency is very high, the gain is high. Gain is high because this is not effect here. There is no loss of input. There is no loss of input. Plus, this is from here you can see gain is also increasing with high frequency. With high frequency, this is 0. Okay, I don't understand these things. So depending on this formula, now we'll do some problems, and you know how to find the input resistance and output impedance. Those things we also discussed in the class. Now, if this point is clear to everyone, if you're in doubt, please ask what I'm saying here. If my is not clear.
सर
Hmm.
सर स्मॉल आरई के बारे में बता दीजिए.
Small R is a ammeter resistance, है ना? Whenever there is a transistor, this is a PN junction. Okay, so this PN junction can be replaced by a small resistance RE. A small signal model we discussed, na? If there is a PN junction, this junction can be replaced. A diode can be replaced by for a small signal. A diode can be replaced by a small resistance RE. Okay.
Okay, sir. Thank you.
And you know how to calculate what is the formula for RE? Do you remember? This is 26 millivolt, or you can say 25 millivolt upon how much current is flowing through the diode, how much current is flowing here. And what is the current here? IE. In the case of ammeter, IE, this is the formula for RE. Okay. So this way we can find the RE, and this will be given, RE will be given, RC will be given. Directly I can find the gain. Okay. So let us solve one or two problems on the gain. I'll give the solutions also, don't worry. Let us discuss first here. So I have to draw a circuit again. So the question number 1 says, for a circuit shown in the figure, find the DC bias level, DC voltage across the capacitor. Okay, DC voltage across capacitor, AC ammeter resistance, voltage gain, and state of the transistor. Okay, this is a quite big question. So say this is given a resistance R, So I'll solve one or two problems because all are same only. So I'll just show you how to do it. Okay, and then I'll give the solutions. So this is 40 kilo ohm. This is 10 kilo ohm, and this is your 1 kilo ohm, and this is here, and here you have a VC capacitor, and you have here RL equals to 1 kilo ohm, and this is your plus 15 volt. Okay. So the question first is, find the DC bias level, DC voltage across the capacitor. Okay. And AC ammeter resistance. Okay. So first, basically, you have to solve for DC. The circuit first you have to solve for DC. Solving DC means, tell me what? Solving DC means what? This is C1, C2, and here capacitor is one more capacitor is there, CE. Okay. Solve it. This is 2 kilo ohm, RC is 2 kilo ohm. RC is 2 kilo ohm. Beta is given 100. Okay. बताओ कैसे करेंगे? First of all, what we'll calculate? First of all, we'll find out what? IE, because I want to find RE. So what is the voltage here? Tell me. If I use for DC analysis, first case is for DC analysis. For DC analysis, what I'll do? Capacitor will be open. So capacitors are open. So this is out of the picture. Okay. Now find the value of ammeter current IE here. Find the value of IE. So for find the value of IE, generally we use approximation method in voltage divider. So I'll find what is V2. So my V2 is, tell me how much V2 is there?
R1 plus R2 by R1 R2.
So this is 50 kilo ohm into 10 kilo ohm. Okay. So this is 150 divided by 50. So this is 3 volt. Tell me yes or no?
Yes, sir.
Okay. Now VB is given in the question, or if it's not given, you can take 0.7 and tell me what is I. Tell me what is I is coming. What is I is coming? Okay. So I'm not solving, you to solve. Okay. Tell me what is IE is coming. So here, now this is 3 volt. This V2 is 3 volt, and this VB is 0.7 volt. Okay. So I can find what is VE here. So my VE will be VB V2 minus VBE. So this is 3 volt minus 0.7 volt. So this gives me 2.3 volt VE. And that gives me IE value. IE will be VE, this VE divided by this RE. So 2.3 volt divided by 1 kilo ohm. That is 2.3 milliamps IE. Okay. And once you know the IE, okay, and now you know the V2. So V2 is what? V2 is the basically for DC for DC analysis, I'll make AC 0. So this is V2 is basically the voltage across capacitor C1. Okay. So that is answer you can directly write. Similarly, now you can find what you can find I, you know. Now you can find what? Tell me. IC. What will be the IC? IC will be almost equal to IE, that is 2.3 milliamps IC. And tell me what is your VCE? VCE will be this VCE will be VCC minus IC RC plus RE. Tell me what is the value of VCE? कितना आ रहा है? Directly you can find, because VE already you know. VE already you know, so you can find only VC, then also you can find IC. Okay. Instead of finding VCE, you can directly find VCE minus RC. Okay. This voltage drop here, remaining will come here, VCE. Okay. And VC you calculate, VE you already know, you can find VCE. Okay. Tell me what is VC. So this is 15 minus IC is 2.3 milliamps, and this is 2 kilo ohm. So this 2 to cancel. 15 minus this become 4.6. 4.6, this will come how much? 10.4. 10.4 volt VC. So VCE will come 10.4 minus VE is 2.3 volt. 2.3 volt. So this will come how much? कितना आएगा बताओ? 8.1 volt. 8.1 volt.
Sir,
Ah.
in the question, there are some terms used like the DC bias level, DC voltage across the capacitors. What does that mean? Can you just explain?
Yeah, I'm telling you. So पहले just say what is the value is VC is correct ना?
Yeah,
Okay.
it's correct.
So VC we have a now we have a we can tell what is the operational region is what, active is what. Okay. Now it is asking what is the voltage across the DC voltage across the capacitor. Okay. So DC, whenever I make DC analysis, what I'll do, it will behave like an open circuit. Yes or no? Shalin, if it is DC, I'm doing DC analysis, I can make this capacitor as open circuit. Yes or no?
Yes,
Okay.
sir.
And for that I have to make AC 0.
Yeah.
Okay. So here you have a capacitor, and here I'm not measuring output. So say 0, and here is VC. Okay. And here you have a capacitor, this capacitor, okay, which is open now. Of course, it's open now for DC analysis. So they're asking what is the voltages across these capacitors. So what is the voltage across these capacitors? Across this voltage is V2, is across C1, and
VC across C2.
and this VE across. Okay, this V is across C3. That is the meaning of DC. Okay.
So, and sir, bias level means we have to find the voltage across R1.
DC bias means finally you want to find this IC, IE. Okay. Whole DC analysis. Okay. Because our purpose is to find RE, na?
Yeah.
Now what is RE?
We have IE, so 26 by IE.
26 millivolt by IE is how much? 23.
2.3.
2.3 milliamps. Okay, so let me. So how much coming answer? RE. You can use 25. Okay, because in the question they are using 25. Okay, 25. So how much will come?
10.8.
Okay, 10.8 or 10.8 ohm. Okay, very good. 10.8 ohm. 10.8 ohm. Now you know RE. Now directly you can use the formula for voltage divider and you can find the gain. What is the gain? Tell me. Gain का formula क्या? Gain का formula is
beta
No, beta gain.
Beta
AC gain. AC gain is
beta
what?
Ig. Beta Ig.
RC by RE.
Generally we write RC by RE plus RE plus RE also there. RE plus RE, generally we write this one. Okay, and I'm doing this for high frequency, so RE will be also removed. I'm doing for high frequency, na. This is for if it's not given anything, that means you're doing for high frequency. So this becomes short, so this will be removed. RE will be removed. The basically formula is RC by RE. But in the question, there is a one load resistance also given. What is the value of load resistance? कितना है?
1 kilo.
1 kilo.
1 kilo ohm. So now if I do it, if I make a equivalent circuit of this one, you know how to do it, okay? So I'm not repeating this thing. So now what will come when I do this analysis, okay? This will be grounded, and this RC will come here, plus RL will also come here. Okay, so the output resistance, I can write this is the output resistance, the RC dash, which is RL, RC parallel to RL. This output resistance. So now my gain formula will be what? AV RC dash upon RE. Okay. Now find out value, you know, this is 10.8 ohm and RC parallel RL. RC is how much? 2 kilo ohm. 2 kilo ohm. Okay. So 2 into 1 kilo ohm, 2 and 3. So 2 is 2 by 3 kilo ohms. Okay. So this is 2 by 3 kilo ohm. Tell me how much gain coming.
Sir,
कितना आ रहा
how
है?
you have drawn RC there?
क्या बोल रहे हो?
Sir, RC.
आरसी वैल्यू तो दे रखा है ना 2 किलो ओम भी। इसको जब हम इक्विवेलेंट सर्किट बनाते हैं एसी के लिए, तो क्या करते हैं? इसको ग्राउंड कर देते हैं, तो ये यहाँ पे आ जाता है, इधर आ जाता है, ये रेजिस्टेंस सारे कहाँ आ जाते हैं? इधर आ जाते हैं। दिस इज हियर, दिस इज 40 किलो ओम। हियर यू अप्लाइंग V input through capacitor, and this becomes short now. This becomes short now. This is your RE, which I will change by beta RE. तो भाई ये तो मैंने डायरेक्ट फॉर्मूला लिखा है ना। अब I'm not going to solve everything. You have to just, we have already solved this in the classroom, what is the formula. So I'm just going to use this formula now. I'm not going to solve everything. Okay, so this is formula now, and you know the RC, this will be this one, and RE we already find out. This is the formula. Put it value, how much is coming?
61.7.
So around 60. Okay, so this is around 60, the gain of the circuit. Okay, let me do one or two problem more. What is second question? For circuit shown in the figure, determine the current gain, the voltage gain, okay, current gain, voltage gain, and the power gain. Okay, so this is your homework. I'm going for question number 3.
Sir, how is the power gain calculated? It's the output power by input power.
Voltage gain into current gain. Power gain is equal to voltage gain into current gain. Okay. Now question number 3 is what? Tell me 3. Determine the input impedance of the amplifier. What is the input? How do you find input impedance? Can anyone remember? What is the formula for input impedance? So this is a capacitor. This is this is your
The V input upon R in.
बाबा कुछ रिवाइज नहीं कर रहे हो तुम लोग। अभी थोड़े दिन पहले तो कराया क्लास।
Sir, we take a parallel combination of
Yes,
IB and the resistance that we have.
yes. Okay, so this is your 45 kilo ohm, and this is your 15 kilo ohm, and this is your capacitor. this is like this, okay, and here you have a RC is equal to 10 kilo ohm, and then you have a VCC plus 30 volt, and here you have a capacitor, beta is given 200, okay. Now for input impedance, okay, in order to find the input impedance, what I'll do, first I will do a DC analysis, okay, and by doing DC analysis, first of all I'll find what is the value of RE, okay, what is the value of RE. So in order to find the value of RE, I want what is IE, okay. So first DC analysis, this is open, this is open, and this is open. So this voltage is say VB or V2. So VB is how much? 30 upon 45 plus 15, 60 kilo ohm into 15 kilo ohm. So this is 1, this is 4, and this is coming out 7.5 volt, okay. And your VE here, this VE will be 7.5 minus 0.7 volt. That is how much? 6.8 volt. And once you know the 6.7 volt, 6.8 volt. Now tell me what is RE value? IE will first find out what is the value of IE. कितना आ रहा बताओ? How much is the value? Now I can
6.1 volt.
6 point. No, this is 6.8 volt. Okay, so just for simplification, I can make it 6.5 kilo ohm. Okay, so that my current will become simple. Okay, I'll make resistance. So my V is 6.8 volt. Correct. I will be how much? 6.8 divided by 6.8 kilo ohm. That will be 1 milliamps. Yes or no? Now you know the IE value 1 milliamp. Okay, you can find the RE. RE will be how much? 25 millivolt divided by 1 milliamp. So this will give me 25 ohm RE. Okay. So once you know the RE, okay. Now for AC analysis, what you'll do? AC analysis circuit. This is your RE, and now AC analysis. This all will be grounded. Okay, so you will be having V input here, and this is grounded. So I can write this is a 45 kilo ohm, and this is your 15 kilo ohm. This is also grounded. Okay, connected to the base, and here you are, and this base emitter junction. This one I will replace by a resistance of beta RE. Beta is 200. RE is how much? 200 into RE, 25 ohm. So this becomes 0, 0, 50, 5 kilo ohm. This becomes 5 kilo ohm. And this is my base. Okay. This grounded. And this is my, so basically here I can find the input current is this one, IE. I can find what is my input resistance. So input resistance will be, say R input will be V input divided by I input. Okay. So you should know all the resistors values of this resistances. कितना है बताओ? So R input will be basically 1 by 15 plus 1 by 15 plus 1 by 5. Tell me how much is coming? कितना आ रहा है? So this is 1 by 45.
45 by 13.
So this is 45. This is 1 plus 3 plus 9. So Ri will come 45,
3.46.
3.46 kilo ohm. Okay, this is your input thing. Okay. अभी जिसने कर रखा है उसी समझ में आएगा, जिसने बिल्कुल नहीं कर रखा उसको क्या समझ में आएगा कि मैंने ये कैसे किया. ओके, so ये just I'm in short I'm doing. Okay, so this register, this junction will be replaced by a resistance of beta Re. Okay, so beta Re plus this one, they'll give you the input resistance. Okay. Now question number 4 is very interesting. Okay, that is a new thing which I didn't discuss, that I want to discuss now. Okay, question number 4. What is the question number 4 here? Give me 1 minute. So question number 4 gives you, select a suitable value for the emitter bypass capacitor. Okay, that is CE. If the amplifier is to operate over a frequency range of 2 kilohertz to 10 kilohertz. Okay, so this question is very interesting. This type of questions I did not discuss in the class, so I'm discussing here. So it's very simple. So you have been again voltage divider bias circuit. This is 6.8 kilo ohm. This is 20 kilo ohm. So this is a basically frequency response of a BJT. How BJT, while working as an amplifier, responds to different kind of frequency. Okay, and this is your plus 12 volt, and this is CE. This is grounded. This is 560 ohm. Okay, RC is 1 kilo ohm, and here you are putting a capacitor CC collector capacitor. This is a base capacitor, input capacitor, C input. Now you have to find the value of CE. Okay, what is the frequency range? Tell me, what is the frequency range? Frequency range is from
2 to 10
to 10. 2 to
kilohertz.
10 to kilohertz. Okay, this frequency should pass. Okay, this should you should get the gain for all these frequencies at least. Okay, and this is my minimum frequency. So you have to always understand, if you want to pass a minimum frequency through this capacitor. Okay, because DC it is open, it will not bypass. DC it will not bypass. Okay, AC it will bypass everything, so gain will increase. Now if this frequency range, I want to find what is the value of this, at least what is the value of this capacitor, so that this frequency should pass. Okay, so the general rule is there that your XC of this capacitor, XC should be equal to 10 Re. This is a rule. Okay, if you want to find the if you want to design a CE for minimum frequency, then your XC of this capacitor should be at least 10 times of your Re. So from here I can find what is my XCE. So now Re already I know. So XC will be what? XC will be 10. Re is 560. So this become 5,600. Now, so I know this value, XC value, this one, and I want to design for minimum frequency. The minimum frequency means XC is equal to 1 upon 2 pi. F is your F minimum. F is minimum here, minimum. CE equal to 560. Okay, from here you can find the value of CE. What should be the value of CE? Okay, so CE will be what? CE will be now 1 upon 2, 3.14. F minimum is 2 kilohertz. Okay, and is 5,600. Tell me what is the value of C?
Two 2.4.
Hmm?
2.84.
2 point or 1.42?
1.42.
1.42. The answer is 1.42. What? Unit is what? Nanofarad or microfarad?
It will be in farad, right?
No.
Okay, kilohertz. So it will be milli then.
Let me check. What is the answer? It should be microfarad. Okay, microfarad. This is microfarad.
Sir, how shall?
Check it. Calculation you have to do it, na?
No, we only use frequency in kilohertz, right? The
And this is
resistance was in ohms.
this is 5,600 ohms. So 5.6 kilo ohm, na?
But we use 5,600 when we divided.
So what is the calculation? Calculation is coming. Tell me what is the calculations?
1.42 into 10 raised to minus 5, yeah.
That's what I'm telling, na? Either microfarad or millifarad calculation. You have to check what is coming. Okay, what is the value here? If it's 60 ohm, and this is 5,600. Okay, so I have answered microfarad. You may check it. Okay. Now do it the last question. Do it the last question. And then we'll go to the next sheet, which is very easy. We already done. Okay. In the class also. So say, what is the next question? It's a voltage regulator basically. Regulator circuit. So you have this one. Okay. This is your Gina diode here. I'm putting here. This is grounded. Here you have a resistance A, and here you are applying some B input, which is 22 volt, and this is 130 ohm, and this is connected here, and this is going here, and this is your RL is 100 ohm. Okay. I load is coming here. This is ammeter current, so obviously this is your IC. Is IC, and this is your IB. Okay. And VB, and this is your 8.3 volt. This is your 8.3 volt. Okay. 8.3 volt is required. So question asking, what is the output voltage here? What is the output voltage here? And you have to find the IC, IB, you have to find the current values. Okay, IS, IZ, IS, you have to find the IZ, IL. Okay, find the values, current values. What is the collector current? What is the load current? And what is the V output? So first of all, tell me whether this zener is on or off. It require 8.3 volt. So whether this zener is on or off. Can tell you, anyone tell me? Gautam? Ajad?
It is on, sir.
It is on, okay. Because if I make it open here, okay, if we make it open here, this point is how much?
22 volt.
Huh?
22 volt.
How 22 volt? Why?
The voltage applied is 22 volt, right?
So if I make it open this one, then current is
Okay,
not.
across is 22 minus 0.7 will be there, right?
No. See, this is open. If it is open here, now this path is completed, na? This path. Okay. So you can find how much current is going here. What is the drop? What is the drop here? What is the drop here? What is the drop here? So you can find what is the voltage here. Okay. And once you know the voltage here, so how can you do it this one? Just 1 minute.
Sir, can I ask one thing?
Yes, tell me.
Can't we just find the difference between those 2 points? The
Hmm.
first point is directly connected there, so there will be the voltage
No,
22.
First, which one? Which one you're telling? This one, and this
And
one.
the B point. B.
This B is what? This one.
Ah.
So what is the difference? That's why I'm asking. What is the difference?
Okay.
How to find the difference? If you don't know this potential
So
of
the
this point, if you don't know the potential of this point, how do you find a difference here?
I understood.
Okay. So for that, you have to find what is current here. Okay. So now this is 230. If I say this path, I can find what is I. But here IC is also going here. So that you have to see how to calculate. Okay. Just let's check the questions once more.
I have.
Anyone else can tell me how to approach this problem? So I
सर
check.
भी अपन कैलकुलेट कर लेंगे
कैसे करेंगे कैलकुलेट बताओ
22 into 100 by 130 plus 100
how if very good. Say if I make this open, okay, then there is no bias. So my IB 0, so IC 0, this is 0. So current is only going here. Okay. So what I can say, I can measure my I will be V input, that is 22 divide, and resistance is 130 and this 100, this is 230. Okay. This is current and the voltage drop here is 130. What is the voltage drop across 130 ohm? Tell me. ये कितना आ रहा है?
so 12.43
12.43, and now you are 22. So remaining here is coming more than 8.3 volt. Okay, that means now I can say this you require 8.3 plus VB is 0.79 volt. 9 volt. So the requirement here is 9 volt. This plus this one, which is this is higher than this one. So I can assume this is on. Okay. So this is on. So when this is on, I can replace this by a battery. I can replace this by a battery of 0.8.3 volt, and BB is my 0.7 volt. Okay. Now I can find directly what is my V output. So V output is this one. This is a plus minus. This is a plus minus. So I can go from this path here. So I can write minus VBE minus this VZ, okay, plus V naught equals to 0. So V naught will be 8.3 plus 0.7, that is 9 volt. Okay. Now this is 9 volt. Once you know this 9 volt, okay, you can immediately say what is your this current IS. Okay, so you can find the IS. IS will be 22 minus 9 divided by 130 ohm. How much is coming? IS, tell me. What is the value of IS? कितना आएगा? This is 13 upon 130. Okay. So this is say
0.1
0.1. What, ampere or milliampere? Ampere, huh?
ampere sir.
Okay, that is 100 milliampere. Okay, 100 milliampere. So 100 milliampere current is coming here. 100 milliamps. How much current is going here? Tell me. IL is how much? IL is voltage drop 9 volt divided by 100 ohm. Okay. So this is how much? 9 into 90 into 13 raised to power minus 3. Okay. 90 milliamps. So 100 milliamps current is coming from here and 90 is going here. So remaining will go where? Tell me. Remaining will go where? IC or IZ? So now
I
yours.
see.
So remaining will be your IC. Remaining will be your IC. Okay. So if I say this is coming here. IZ, why not IZ? Why it is the value of IZ? Can you tell me?
Sir, here the IZ will be equal to IB, right?
Yes, and IB is very small. Okay,
So we
because
can
we can
1
neglect
plus,
this.
yeah,
We can
beta
neglect.
IC.
Beta is given the question.
No.
So beta is not given the question. So because this current is IB, which is generally very less, I can neglect this current. Okay, or you can find also. You can also find the current. No, you can find the IB. But now you can when you find it will come in microampere. So you can say my IC will be IS minus this IL. That is 100 minus 90, that is 10 milliamps. Okay, if you want, you can find the IB value also. How do you find IB value? IB value you can find, say, minus 22 volt, minus 22 plus 130 into IS value. Already I know 100 milliamps, 100 milliamps. Okay, plus 8.3 volt. No, but I cannot find IB. The resistance is not there. How to find IB? Here, the resistance value is not given, so it is difficult to find IB. Okay, let's leave it. Okay, so I'll take some 10 minutes break, 5 minutes break. Okay, and then we'll do the sheet number 3. So we'll meet 8:55. At 8:55. Now please open the sheet 3. Okay. And many of the questions in sheet 3, okay, I have already discussed in the class also. Let me do it. Just some of questions which we have not done, we'll do it. Okay. The question number 1 is to operate an NPN transistor in active region, its emitter base and collector base junction respectively should be. Okay. Can anyone tell me what is the active region? What is the requirement for active region? Biasing requirements? Dev Prasad, Manu.
Emitter based thinking is forward biased. Collector based thinking reverse
Yes.
biased.
Okay. So we have discussed in the class, say we have a two junction, EB junction, and then we have a CB junction in an NPN transistor. Okay. So if this is the forward bias and this is the reverse bias, okay, then the operation region, this is the active. Operation region is active. Okay. And if both are reverse bias, then what is the operation region? Tell me. If if the EB junction is also reverse
Cutoff.
bias, cut off. Okay. Because IB will become 0, IC will become 0. That will become cutoff region. Okay. And both forward bias,
Saturation region.
saturation. Okay. And this is reverse bias and this is forward bias. This is just a inverse operation active. We generally don't use this one. Okay. Very little applications are there. So these are mainly 3 reasons. So the option, you can write what is the option, correct option. Okay. The next question is, in the given circuit, VCC is 10 volt and beta is 100. The collector voltage VC, what is the collector voltage VC? Okay. So you have been given a transistor. This is 1K. This is a VCC. VCC is given 10 volt. Here a 10 kilo ohm resistance is there. Okay. Here a 5 volt battery is there. And here you have a ground. Okay. You want to find what is VC here. That is a very simple question. Beta is given 100. Tell me how to do this question. अब मैं करने से फायदा तो है नहीं, तो कर चुके हम, ये सिंपल डीसी बाइसिंग क्वेश्चंस हैं. If I want to find a VC, what should I do? Palak, Pragya, Preeti. If I want to find VC, what I should do?
So we can find IB and then IC.
Yes, very good. So we can find IB then IC. Okay, and once you know IC here, I can find VC by VCC minus ICRC. This will be my VC. Tell me what is the value of IB? Say IB current is flowing here, so minus 5. So what is the value? And this is if it is 0.7 volt. What is given in the question? Okay, it's not given. You can take 0.7. Okay, so I can write now my IB will be what? IB will be this 5 minus 0.7 divided by 10 kilo ohm. Okay, so this is 4.3 divided by 10 into 10 raised to the power 3 kilo ohm. So this becomes 0.43 milliamps. Okay, and multiply by 100. Correct. 10 raised to power 3, 4, 5.
सर आरबी 100 किलो ओम है.
हाँ,
आरबी 100 किलो ओम है.
100 है, सो 100 कर दो. 100, so ये कितना आ जाएगा आपकी? 43
Microamperes.
43
Microamperes.
43 microamperes. Okay. Now IC कितना आएगा? 4.3 milliamps. If this is 100, so IC will be 4.3 milliamps. So you can write now VC will be 10 minus 4.3 milliamps into RC is 1 kilo ohm. Okay, so this will come 5.7 volt. VC will come 5.7 volt. अभी सारे क्वेश्चन तो सिंपल लग रहे हैं मुझे, तो कोई मुश्किल तो लग ही रहा है, एक्सेप्ट क्वेश्चन नंबर 11। वो 11 भी नहीं है, क्वेश्चन नंबर जो है लास्ट वाला सबसे, क्वेश्चन नंबर 20 वो करने का है, बाकी तो सारे सिंपल है। ओके, 4-5 क्वेश्चन करते हैं हम लोग। कौन सा क्वेश्चन करना है बताओ, कौन सा क्वेश्चन करें? से क्वेश्चन नंबर 3 ले लो। आइदर यू टेल मी, वरना मैं ऑर्डर में करता हूँ। क्वेश्चन नंबर 3, so question number 3, say this question number 3, you have been given a circuit and this is your 1 kilo ohm, 2 kilo ohm RB, and this is 20 volt. Okay, beta is given 100, and we have to find the value of RB. Okay, BB is given 0.7 and collector ammeter voltage is given 14 volt. So this is your collector, this is your ammeter, and VC is given 14 volt. Okay, beta is given. So you have to find the value of RB. Okay, so if you VC is given, okay, VC is given, then what you can find? Tell me, if VC is given, VCC is given, VC is given. Can you find the value of IC? Because if I go in the output loop, my VCE generally is what? VC is my VCC minus IC RC plus RE. Okay. So this is given, this is given, this is given, this is given. I can find the value of IC. So IC value will come how much? Tell me. VC IC value will be
Milliampere.
VCC minus VCE upon RC plus RE. That is VCC is 20 minus 14, 2 plus 3 kilo ohm. Okay, so how much comes? 6 into 3, so 2 milliamps. Very good. Okay, so IC is 2 milliamp. So what is the value of IB? Say 2 milliamps is IC. So IB is how much?
C by beta.
B divided by beta 100. Okay, so how much will come? 10 raised to the power 5, 20 microampere. Okay, so now you can write, say this IB is moving here. So now you know IB, you can find VB is given 0.7. You can, and here you know the current IE, you know, which is equal to IC. So you can find the RB value. So RB will be what? RB will be VCC 20 minus 0.7. Okay, tell me what should I write? Or let me write the equation, then we'll solve. So minus 20 plus IB into RB plus VB plus beta plus 1 IB into 1 kilo ohm into RE equals to 0. It is RE. I'm going this path. So I want to find IB is given, RE is given. Okay, I can find RB. So RB will be 20 minus 0.7 minus beta plus 101 into IB 20 microampere into RE 1 kilo ohm. Okay, divide by IB, that is 20 microamp. Okay, so tell me how much is coming. कितना आ रहा है? How much ohm is coming? If I take this is 100, so this will be how much? This is 10 to the power minus 3 and 100, 100, 100, 100, 100 and 200. बताओ कितना आ रहा है भाई? How much after solving this one? So I can say this is 20 minus 0.7. I'm talking approximately value, and this is if I say 100. Okay, this is 2000. This will become 2 divided by 20 microampere. 20 microampere.
Sir, 864 kilo ohms.
Yes, around this will come. Okay, this is 22.7. That is 17.3 upon 20 into 10 minus 6. So around 860. How much coming? 8?
65.
864.
64, 65 ohm. Okay. Whatever is coming. This
Not ohms, sir, kilo ohms.
kilo ohms, huh? Kilo ohms.
Sir, can we do question 9 next?
Question 9. Okay. Question 9 में तो कुछ है ही नहीं. Oh, same ही.
Sir,
हाँ, tell me.
sir, how have you written that -2 there?
This one.
Yes, yes, sir.
So this whole will go, this whole is voltage, na?
No, sir, in calculation, matlab,
So you solve okay, or around 2 आएगा ना, 2 point something आएगा ना, because 101. This is 20, 0.7, beta is 100, 100 into IB is 20 microampere, be 100 into 20 microampere, okay, into RE 1 kilo ohm. कितना आएगा ये सब सॉल्व करके? 2 ही तो आएगा ये.
okay, sir, I
ये-
was making mistake.
2 आएगा. Okay, let us solve question number 9. What is question number 9? The current gain of the transistor in the following is beta is 100, the value of collector current. Okay. So you have this capacitor. So you are getting confused. Still you're getting confused with capacitor. DC analysis, just you have to open. Na? So this is 12 volt. This is 3 kilo ohm. This is 20 microfarad. And this is your V naught. Okay, and this is here you're coming as this is 150 kilo ohm. And this is 20 microfarad here, 20 microfarad here. Okay. So the question is with you. Okay. You can check it. And I'm going to solve here. 3 kilo. So this is the same. There's nothing is there. This once DC analysis, you can open this one. So this is a 150 kilo ohm. Okay, this is open. So this is simple like this. Now क्वेश्चन में क्या पूछा है? व्हाट यू सपोज टू फाइंड? टेल मी.
I see, sir.
IC and beta is 100. Beta is 100. Okay. So in this question, now here current is going IB, here current is going, here current is going IC. So obviously this current is your IC plus IB. This current is your IC plus IB. Okay. And this current is your IE. So you can write easily, very easily. You can find the IB value. So how can you write? So you can write minus 12 volt plus IC plus IB, that is beta plus 1 IB. Okay, so beta plus 1, that is 100 plus 101, 101 IB, and this is 3 kilo ohm. 3 kilo ohm into IB plus IB into 150 kilo ohm. Okay, and then 0.7 volt, this one. Okay, and again then 101 beta plus 1, 101 into 3 kilo ohm. Okay, and equals to 0. So this will give you IB value. What is the IB value? Now 12 minus 0.7. Okay, this is 303, 303, 606 kilo ohm. Okay, 606 kilo ohm plus 150 kilo ohm, plus 150 kilo ohm. So this is 11.3, and this is how much? 756, 756 kilo ohm. What is the value of IB? Tell me. Let me check the answer. Question number 9.
Sir, 14 microamp है.
14. How 14? Okay, 14. ठीक है, जो भी है 14 माइक्रो एम्पियर आ रहा है. Anyone else? किसी और का आ रहा है क्या? 14 माइक्रो एम्प्स है.
Yes, sir, it's 14.
So IC will be how much? 1.4 milliamps. IC. Okay. So question में जो answer I have answer that they have given 1.6 milliamp. Okay. So if you take VB 0, is VB 0 in the question? See, if this is VB 0.7, then answer is 1.64 milliampere. If you take VB equal to 0, then this will come around 1.6 milliamps. So both are correct.
Sir, it is not given in the question.
So then 1.4 milliampere is correct answer.
तो हम इसमें किस केस में VB 0 लेंगे?
नहीं लेंगे. अगर नहीं दिया है तो नहीं लेंगे. अगर दिया है तो अभी सॉल्यूशन में कुछ कर रखा है ऐसे ही. अगर दिया है तो ठीक है, वरना नहीं दिया है तो हमारा 1.4 milliampere is correct answer.
Sir,
Tell me.
while doing this problem, is it okay if we take this IC plus IB approximately equal to IC?
Yeah. But some you can take, no issue. Okay. If options are given, then you can check. But sometimes they tell that numerical answer. Okay. That time we don't know how much percentage they are giving. Generally it will be correct. You can take accurately. Okay. But try to do accurately if they're asking numerical answer in the fill in the blanks. अभी कौन सा क्वेश्चन करना है बताओ?
11, sir.
11 is the current mirror circuit. Okay. Question number 11. Because bases are connected, so you have two op amps connected like this. And here is 100 ohm. This is 5 volt. and this is here, and this is here, and this is connected here.
Sir, is there a connection to that C also? Or
C
I
means
mean that bases are connected to each other. So is that through C or without connecting it? This
this only bases are connected. That is, this point you're saying, this point.
yeah, that point.
That disconnected. Disconnected. This is connected. Okay. Now question में क्या पूछा है? There are identical transistor VB 0.7. The current passing through the resistance through the resistor transistor TR2. Okay. So you'll find how much current is passing through the resistance. Okay. कितना आएगा बताओ? How to do? So say some current I is coming here. Generally we call this a reference current. Okay. Now both the transistor TR2 and TR1 identical. So identical means their VB is same. They're identical. So their V base to emitter both have a 0.7. Okay. Now here current going IB because both are identical. Same voltage coming here. Same point here. Same point here. Then their IB will be also same. So say this is IB. Okay. And this is your IC. So I can say my I reference is equal to this IC plus 2IB. Okay. And IC is identical means their beta also same. So IC will be beta IB plus 2IB. Okay. I can go. I can do KCL here. IR is coming, IB is going here, IB is going here, IC is going down. So this will be beta plus 2IB, I reference. Okay. So now I want to find IC. So this IB will be I reference upon beta plus 2. If I want to find the IC coming here and IC coming here, that will be beta IR beta plus 2. Okay. Now I want to find what is IR. So I can go to this loop. This loop or I can also come from here to here. So I can write minus 5 plus IR into 100 ohm. 100 ohms. 100 ohms is there, na? Not kilo ohm. 100 ohms. Then if I come here 0.7 volt equals to 0. So my IR will become 5 minus 0.7 upon 100. Okay. This is 4.3 divided by 100. So this is 43 milliamps. Okay. 43 milliamps. And this is also almost, if it's 100, this is almost equal to IR. Or you can solve it. So this will, if you solve this one, so your IC will be almost 43 milliamps. For accurate answer, you can do it 100 divided by 102 of 100 divided by 102. That will give you the accurate answer. Question number 12 is also same. Base connected.
Sir,
Hmm.
they're asking the current passing through the transistor 2, right?
Yes.
So which current is that? We have to find IC.
IC. This IC. Okay. Now let me do question number. See, these questions already I have done the class. Let me do question number 20. Okay. Which has a slightly different circuit. Question number 20. So you have been given a transistor. Okay. And the circuit is given like this. C2, R3, R4, then here VCC or VC, whatever is given VC voltage, and this is connected here, and then you have a R5, C3 here, R6 here. Okay, please check whether I'm drawing correct or not. And then this is here, and then you have this R2, and then you have a R1. And here you have a C1 and some AC sources there. And this is like this. Okay. Tell me, what is they asking the question? What is a DC base current? Okay, DC base current they're asking what is IB basically. So this is IB. Okay, this is your IE. And this is your IC. So basically they are asking DC base current approximated to nearest integer value in microampere. Following values, R values are given, resistance value given, capacitor values given, and you have to find what is the approximate value of this one. Okay. So for DC analysis, what should I do? Tell me for DC analysis.
Open the capacitors.
Open the capacitors. Okay, so open the capacitors. So this, if I open this one, this is gone in the picture. This is not in the picture. If I open this one, this is also not in the picture. This DC analysis, this will be short. This will be short. This will be open. This is also, this circuit is also not in the picture. Yes or no? So only we have 3 loops. Okay, we have this loop, R3 and R4, and this loop I have in the picture. And I know I want to find this IB, I know this IC, IE. Here my source is there, VC. Okay, and R1, R2, R3, I5, all values are given. Now this is just to find VB is given 0.7. Okay, VB is given 0.7. Okay, so let us take VB is 0 in this question. If it's not given, we can take 0. So we have to solve now this question. If you take 0.7 also, we can find out. Okay, let us say. So say this is the ammeter current coming here. This is the ammeter current here coming here. Say this current is starting from here is I. So this I current is going from source, I current will come back. And this is the IE, this is IE. So obviously here current will be IE minus I. So you can solve this question in multiple ways. Okay, you have to find IB. So you can solve whatever way you want. I am just doing this KVL. So this IE is coming here. So you can write this current is going IE minus IE. And IB is going here. So this current is going here IE minus I minus IB. And again, this current is getting add here IE. Okay, so this current will become your IE minus IB, which is equal to your IC. This is correct. Everything fine. Is that clear? I current flowing here. I is coming here. Out of I will go here because I is starting from here. This current will go IE minus I here. IB also going here. So remaining current is I minus IB. And I current is coming. I will cancel. So IA minus IB will go here. And I minus IB is IC. So IC is coming here. Now just apply the KVL. I write minus VC. I'm moving opposite to this one. Plus. So I write minus. Because I'm moving the opposite the current, na? Opposite of current. So minus IE minus I minus IB into R4. I'm moving in this loop. Minus IE minus I R3 equals to 0. Okay, this is my first thing. And if I go in this loop, this is VBE 0.7. Okay, so I can write 0.7 volt plus IER2, okay, and I can write plus here IE minus IR3, and I can go this loop equals to 0. So here I can find the value of I minus I. I can put value here, I minus I. Okay, tell me what is the value of I minus I. So basically your I minus I into R3 is your 0.7 minus IE into R2 minus 0.7 minus IE into R2, which you can put here. So this will give you minus VC minus IE. So first let us solve this equation, then we'll put the value. So this will here minus VC minus IE minus I into R4, okay, minus I into R4 minus plus I into R4, okay, and minus IE minus I R3 equals to 0. So what should I do now? I want to find,
So that is plus IB into R4.
which is
Sir, in the first statement, plus IB into R4 instead of IR4.
IB also.
Outside the bracket. Yes, sir.
This is IBR4. Okay. So I can write now my IE minus I, okay, R4 plus R3. I'm bring this side. This is my minus VC plus IB R4. Can I write like this? Okay. And the value of IE minus you can bring from here. So this become minus 0.7 minus become plus. Okay. So this you can write here 0.7 plus IE into R2 R4 plus R3. This minus I'm taking here. This become VC minus IB R4. Okay. Now you can do many ways. I have done this one. Now this you can write this one, beta plus 1 IB. Beta is given in the question. Is beta is given in the question?
Yes, sir.
So bus beta
75, sir.
huh?
75.
Beta is given 75. Okay. Now you can put here 76 into R2 IB, and you can solve this one. Tell me what is the answer is coming. Okay. So you have a 0.6 plus this is beta plus 1, that is 76 IB into R4 plus R3 VC minus IB R4. And now solve this equation and tell me what is coming. 0.7 R4 plus R3, okay, plus 76 IB R4 plus R3 plus VC minus IB R4, okay.
Sir, the right side of the board is not missing.
Oh, अभी तुम ये this is just a calculation you have to solve.
And sir, one more doubt that in the first equation, did we neglect IB?
No, where?
There is
Where?
IE minus I, then minus IB also will be there, right?
Here,
No, at R4.
R4, huh? So IB is there, na?
That is not written in the equation, right?
No, we are written. That's why this IB R4 came, na?
Okay,
IB,
okay, huh.
okay.
Sir,
Now,
in the second last statement, that 76 IB into I2 also there, R2 also there, huh?
76,
IB plus into R2.
R2 also there. R2 also there. Yes. Correct. Yeah, R2 also there. So R2 also there. Very good. Okay. So tell me, now after solving this one for IB, what should come? Okay. So let me write here. So I have a 76 R2. Okay. R4 plus R3 IB. Okay. This one plus IB R4 plus IB R4. Okay. And this is 0.6 R4 plus R3 equal to VC. And I can take this common. No, common, why should be common? Okay. So this VC I can send here minus 0.7 R4 plus R3. Okay. And I also can take common of this. IB common. So IB common means 76 R2 R4 plus R3 plus R4. This is your IB. Okay, I actually don't know what is the answer. Just solve this. Solve this one. Tell me what is the answer is coming. If his calculation correct, please check it and tell me what is the answer. What is the value of VC?
15 mole.
So let us solve this one. So IB will be 15 minus 0.7. Okay. R4, R3. R4 is your 2.6 and R3 2.1. Okay. Please do the calculation. Tell me the answer.
Sir,
Hmm.
sir, as VC is 15 and R4, R3 is in kilo ohm, so negative will come.
नीचे भी तो ये है ना R4 I3 कितना टोटल कितना है
4.7.
तो कम ही होगा ना ये पॉजिटिव आएगा ना 4.7
Yes, sir. Kilo ohms.
हाँ ठीक है ओके किलो ओम्स में है
Yes, sir.
something we're missing that means some calculation mistake is there where is the beta no minus should not come Just 1 minute. Give me 1 minute. I'll check the answer. Question number 20, na? Okay. So the final IB formula is VC. Okay. Just 0. ठीक है, VC R3 beta is your 75 R2 R3 plus R4 is correct only. Just check it if you have done any mistake in the calculation. Okay, I'm writing the equation again once more. Okay, so we have two equations. Tell me.
For IE minus I, we substituted minus of RE plus 0.7 only, right? There will be divided by R3 also.
This one here. Divide by R3. Okay, now do it. R3 is how much?
R3 is 2.1 kilo ohm.
2.1 kilo ohm. Okay, so kilo ohm cancel. Now I think it should not come positive. Okay, and then check it this one also. What is coming? Because what finally I have the formula. IB. Okay, if I take VB is 0, then this whole part becomes 0. Okay, now you please do it calculation. Now everything is changed. Tell me what is coming.
So I'm not getting y divided by R3.
So shall I do it again? Shall I write the equation full? Okay, let me write the equation again, and we'll
But
do now.
only then it will be dimensionally correct, right? Otherwise, it
yes,
won't be.
yes. So let me write the equations again. Okay. So the equation number first is I'm going from VC. Okay. So minus VC, and then I have minus IE minus I1 and minus IB R4. Okay. And then I have a minus IE minus I1 into R3 equals to 0. This is my first equation. And my second equation is this one. Okay. So VB IE R2 plus here IE minus I1 R3. Okay. Plus VB equals to 0. This is my equation. Two equations. And now you have to solve these equations. You can put the values of R1, R2, and then you can solve. You can make a simple equation. Put the values of this one and make a simple equation.
Yes, sir. Now good.
कितना आ रहा है? Can we do it some other way? If I say I minus IB, IC. This is also IC. So what I did like this. I put I minus I1 into, if you can put VB also 0, because the approximate answer, na? If you can put VB is 0, then you can simply write this your I minus I1 will be your how much? Minus of IE R2 upon R3. This also you can use if you don't want to use VB. Okay. Or for accurately, you can put it VB also here, minus VB. कितना आ रहा आंसर? किसी का नहीं है अभी तक. So So I minus I win. This is minus VB. Okay. Divided by R3. And this is here.
सर क्वेश्चन में सिलिकॉन दिया है ट्रांजिस्टर तो 0.7 तो हम ले सकते हैं।
हाँ ले लो ले लो ले लो, क्या दिक्कत है? अब बस पुट करके बताओ आंसर क्या आ रहा है। ओके, इसका वैल्यू तो यहाँ से पुट कर देंगे आई का। ओके, तो दिस इज माइनस वी सी। ओके, माइनस आई वन इंटू R4. ओके, एंड माइनस माइनस प्लस आई बी R4, and this is your minus IE minus I1 R3 equals to 0. Now I'll take this common. Okay, so minus VC plus IB R4 equals to IE minus I1 into R3 plus R4. And this is minus VC plus IB R4. Okay, I'm putting the value of this one here, minus IE R2 minus VBE upon R3 into R3 plus R4. Okay. Now just solve this one. IB R4 let it be here. IB R4 will be here. This will become now VC.
Sir, answer is coming in nanoampere.
Microampere or nanoampere?
So 10 to the power minus 9.
और value क्या है? What is the value?
4.8.
No. VC. Okay, VC, and this is minus. Okay, minus I is your beta plus 1 R2 IB R3. Okay, and this is minus VB upon R3. So this is into R3 plus R4 into VC. So this will give me what? Minus, what should I do? I want IB. IB should go there. Okay, IB part should go there. So this will become now IB R4 plus beta plus 1 R2 upon R3 equals to minus VB, okay, R3 plus R4 upon R3 plus VC, almost same is coming. Okay, and now IB will be this one, VCC minus VB R3 plus R4 R3 upon R3, and this R4 plus beta plus 1 R2 R3. Okay,
So 0.19 microampere.
no, it's around 20 microampere should come, 20 or 22. So IB will be now, VCC is your 15 minus,
Say 21.96 microamperes.
yes. So this is 0.7.
19.6.
0.7. Okay, R3 R4 is how much? Tell me. R3 R4
4.7.
And divided by R3 is how much? R3 is how much?
2.1
2.1.
kilo ohms.
2.1 kilo ohm ना?
Yes, sir.
बस ये आ गया. R4 कितना है? What is R4?
2.6 kilo ohm.
0.6 kilo ohm. And beta plus 1 is 76. R2 is 2.1 kilo ohm. Oh, R2 is how much? R2 कितना है?
4 kilo ohm.
4 kilo ohm. And R3 is 2.1 kilo ohm. 2.1 kilo ohm. इसको सॉल्व करना है. बस कितना आ रहा है? So this kilo ohm cancel. Okay, this kilo ohm cancel. And solve this one. Tell me how much coming. Shalin, how much coming? This value. So this should come around
Sir, I am getting around 15 microampere. I'm doing it again.
this
Sir, 21.96.
21.96. And if you remove this part, then it may be around 24. If you remove this part, only solve for 15 upon 2.6. Okay, and then this one around, I will roughly do is 2 into 76. 2 into 76. Okay, so 2 into 76. If you solve this one, then it should come around 2.6 and 10 to the power 3. 5. No. If I solve this one, how much should I get? Tell me. For this one. So this is some 20, 15 into 3, 5. No. It's you gotta solve. Okay, we'll stop here now. You do the calculation, tell me, and I'm sending the solutions. The remaining problems are very simple. So tomorrow we'll start this OPM. Okay, so tomorrow you must come. So this is your transistor 2 solution. Transistor 3. Transistor 3 and crash sheet 2 and sheet 2 solution. I'm sending. Yes. How to send sheet 2 solution. And sheet 3 solution. How much coming, Sharlene? Have you solved?
I'm getting around 15.8 for IP.
Check it, please. Any
Yeah.
other student? Any other student? Vijay batch. And then crash course batch. Okay, thank you. Vishal, Vishnu, have you got anything? Manu, तुम्हारा आंसर आ गया था क्या?
Sir, 19.6 I'm getting.
अच्छा, ये लिप्सा तुम्हारा कितना आया?
Sir, I am also getting 19.6.
Okay, तो आंसर भी क्या दे रखा है? ऑप्शंस भी क्या दे रखा है?
Sir, I am getting 21.96 microampere.
Okay, अब सबका अलग कैसे आ रहा है? फॉर्मूला तो सेम ही है. ऑप्शन में so we have to see the options. Okay, which is closest. If you 19%, then the answer is 20. Okay, so I have to check the answer. I have to check the answer. and then I'll tell you what is the correct answer. Solution may be wrong. Okay, in the solution there may be issue, but we have to see the accurate calculations. So I'll check the answer and tell you tomorrow. Okay, thank you. This is
Thank you, sir.
old solution, so there may be some problem. Okay, we have to check the answer key, actual answer key, and we have to see then what is the answer. Question number is 20. Is just 2017. Okay. So I leave. Thank you.
Thank you, sir.